Hi there, algebra students. We are now starting chapter 5, which is all about functions. We're going to talk a lot about linear functions, and you might be thinking, I know we've talked about linear equations, but what on earth are you talking about, this function? Well, it's kind of the same thing. A function is a relationship that pairs every input with exactly one output. Input being the x values, output being the y. So the set of inputs are x values. New word for you, that's called the domain. And the variable that represents the input values is the independent variable. So that's the one that you pick. The set of outputs or y values, that's called the range. So the variable that represents the output values, that's going to be the dependent. So that's usually the one where you have to gather the information on, you have to actually do an experiment, and you get those values. You don't get to pick them, they're what happens. All right, so what are relations? Relations pair inputs and outputs together. It's like the relationship between x and y. Relations can be written in the form of. Now there's a whole bunch of different ways we can write relations, and these aren't new. I know you've seen these before. One way we can write a relation is using an ordered pair. There's your x, there's your y. It's their relationship together. You've also seen relations in tables. Again, the 2 and the 10, they go together. They form a relation. Also on a graph is made up of a relationship between your x values and your y values, and those points have a relationship. A new one you might not have seen before is called a map. So we have all of our x values in order, we have all of our y values in order, and we have arrows bringing the two together. So in your table we see that 2 and 10 go together. To show that 2 and 10 go together, there's an arrow drawn from 2 to the 10. And then we have 4 matching up with the 8, 5 matching up with the 7. So kind of a little messy way, not my favorite way, but it is a way you can see them. All right, well, when you're listing the domain, because that's kind of a goal today, you're going to have to be able to look at any one of those ways relations are expressed and tell me what the domain and the range is. So the domain, the x values of a relation listed, those should be listed in order from least to greatest, and you don't need to repeat any that appear more than once. So how you would list it, the domain, you would put a capital D, dot, dot, and then we're going to put some little fancy brackets. Do your best, and I'll do my best. I'm not the greatest at making those. And then choose any one of these relations to look at. I'm going to look at the ordered pairs. And when I'm trying to find the domain of the ordered pairs, that just means I'm going to look at all of the x values. It's a good idea. You should underline those too. Go for it. So I see I have 2, 5, 4, 7, and 10. Those are the values in my domain. When you list a domain, you want to put them in order from least to greatest. So in looking at this, I see it's going to go 2, 4, 5, 7, 10. So I'm going to write that. 2, 4, 5, 7, 10. And then I'm going to close up those brackets as best as I can. I know, it's a mess. All right, to list the range, all we have to do now is look at the y values, and we're going to list those in order without repeats. So when we look back up to the ordered pairs, I see I have 10, 7, 8, 4, and 1. So I'm going to list the 1 first, and then the next lowest would be 4, then 7, 8, 10. So for the range, again, fancy bracket time, the lowest we said was 1, and then 4, 7, 8, and 10. Now I could have chosen any relation that I wanted. If I would have looked in the table, I could have just looked across the top and said, okay, 2, 4, 5, 7, 10, that's my domain. And then 1, 4, 7, 8, 10, that's my range. So you could have looked at it that way as well. Same thing if you're looking at a map. The x values are your domain. The y values are your range. Actually, as much as I don't like the map, that probably would have been a little bit easier, right? Because look at, they're all in order for us. All right, so anywho, go ahead and turn the page. Don't you wish that was the end of this lesson? Be like, wow, that was super easy. My easy button. Okay, I know the next page looks kind of busy, but it's not as busy as you think. It's not too bad. It's just some examples. Okay, So a function. We talked about all the different kinds of relations and ways to express relations. A function is a special type of relation where each x value, input, is paired with only one y value, or output. No cheating in this relation. All functions are relations, but not all relations are functions. I know, it's hard to take in. So every single function that you see, if it's a function, it's automatically a relation. But a relation is not necessarily a function, because remember, relations can be expressed in a table, in ordered pairs, in a graph, on a map. Those all show me input and output values. But a function is a special kind where every x value is only paired with one y value. So we kind of have to do some examining to determine if this is a relation or not. Or I'm sorry, if this is a function or not. Forget I said that. Okay. So basically, you can tell if a relationship is a function from a table, map, or ordered pairs, or graph, by checking out the x values. If the x does not repeat, it's a function. So if you don't see the x value more than once, that means it's a function. Okay? So again, every x value can only be paired with one y value. And the reason for that, I drew a little exciting input-output machine. I am sure you have seen these things in your past. If not, there we go. We have this little machine that looks kind of like a Tootsie Roll. Yeah, it's early in the morning, so it does not make me want a Tootsie Roll. It might make you want one. And here's my machine. This is my function. It's y equals 3 times x. Okay? Input represents our x values, and output represents your y values, right? So if I put -2 into this machine, that would mean I would be taking y equals 3 times -2. My output is -6. And when I say that I can't have the same x value repeating with a different y value, if I put -2 into this same exact machine, is it possible to get anything other than -6 again? No. Okay, so you can't repeat the x value. It doesn't work. So you can't use the same x value and get two different y's using the same equation. So that's why x cannot repeat. Or you might hear me say in class, x no repeat. That's how I remember it. Well, that's how I found other people remember it, and I just go with it. So there's my fancy machine. Hopefully it helped this make sense. So when you look at this, as I look at the domain, the x values, I see I don't have any repeating. And do you see how each value has only one line going away from it? This is a function. I can tell because if you trace every single x, there's only one y value for every x. There's only one arrow coming from each x. So this one would be a function. If you look at the second, I know you might look at this originally and think, oh, that's not a function because this y value, it's used over and over again. Right here, this is the y repeating. X is not repeating. This is a function. There's only one arrow coming from each x value. It just so happens that no matter what I plug in, I'm going to get -6. So it is a function. It's just really boring because you get the same answer every single time. All right, last one. This is your example of it's not a function, because if we look at our x values, do you see how this 1 has more than one arrow coming after it or coming out from it? 1 can't have a result of 0 and of 15. So it's not a function because there's two arrows coming from the 1. The number 1 is associated with two different ranges. So this is a relation, yeah, because relationships are expressed in a map like this, but it's not a function because this x repeats. All right, so if you look at a map, a table, some ordered pairs, if you see the same x value appearing more than once, that means it's not a function. It's a relation, but not a function. All right, now if you're looking at a graph, you can tell if a graph is a function by performing the vertical line test. It sounds very, very complicated, but it's really not. With the vertical line test, all you have to do is draw a few vertical lines through the graph, and if it only touches the graph at one point each time, that means it's a function. Yes, because if you drew a vertical line and it ended up hitting your graph more than once, that would mean that the x value would be repeating. So take a look at this line. This is what I'm talking about here. Now, I'll use a different color. Let's go with green. If I just draw some vertical lines through this, we can see that each time it only touches the graph one time. And that gives me my x values, basically, because over right here, this represents x, 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 x. It only passes through one point, so yes, it would be a function. Take a look at this next one. This is going to happen to you soon, this lovely little graph. I won't let the cat out of the bag, but you'll see soon. When I draw my vertical lines through this one, I can see that when I draw the line, it only touches this graph at one point. That means, yes, this is a function. There are no repeating x's. When you look at this last one here, when I draw my vertical line, no matter where I draw it, it hits this graph in two places. Think about what these ordered pairs would be. Let's say that this was over 1. Okay, this is my x-axis. When I go over 1, I could get a result of 2. And for that same x value, I could get a result of, let's say, 4. So having this line hit the graph in two places means that I have an x value that's repeated, because I go over and up, over and down, but I'm going the same amount over. And that amount that you go to the right represents your x. So this would be no, it would not be a function, and it's because this vertical line shows me that I have x repeating, and x is not allowed to repeat. All right, last page. Hopefully you're feeling a little less overwhelmed by the 3 pages of notes, because it's going pretty quick. I'm at 11 minutes right now. I'll try to wrap it up, make like a present, wrap it up. So basically what I want you to be able to do right now is look at some ordered pairs, some tables, some graphs, and tell me what's the domain, what's the range, and is this a function or not? I know they're all relations because relations are expressed in ordered pairs and tables and graphs, but I want to know, are these relations functions? All right, so step A, I ask you for the domain. So in looking at this data, remember the domain are all of your x values listed in order. So I'm going to make a capital D and my silly little brackets. And when I look at these values, the lowest value is -5, so that one's done. Then 0, 2, 5, close it up. I don't have any repeating values. This is good. I didn't have any I had to leave off, and they're all in order. Letter B asks us to list the range, so I'm going to put a capital R and look at all my range values here. And in my range values, I see the lowest is -20. The next lowest is -8. Then I have 0. Then I have 7. Okay, letter C, I want to know, is this a function? All I have to do to determine if it's a function is look at my x values. Look at your domain. Do you have any repeating x's? There's no repeaters. So yes, it's a function. All right, look at number 2. Same thing, and looking at this, I think I'm going to zoom in on yours just a little bit. All right, so my domain for this, when you look, I see 1, 1, 1, 1. Well, I don't have to list 4 ones here. I'm just going to write the number 1 because that's the only value I have in my domain. In the range, the lowest one I see is a -2. And then we have a 0, and we have a 3, and we have an 8. Now C asks, is this a function? Do you see how x repeats? X is cheating. There's no function going on. It's not a function, it's only a relation. So we're going to say no, x repeats, not allowed. Okay, look at the table. Same kind of thing here. To find my domain, I'm just going to look at my x values. To find my range, I'm going to look at the y. Oops, I meant to make that an R. Go ahead. You write in pencil, so you should be okay. All right, here's my domain. 3, 5, 2, 8, 6. In order from least to greatest, I see a 2. Then I have a 3. Then 5, 6, 8. I didn't have any repeating. For letter B, for my range, I see the lowest would be a 4, then a 9, then a 25, 36, and 81. I don't have any repeating x values, so yes, this is a function. Look at your next table. I'm guessing you're seeing my pattern going on here. Yes, no, but just bear with me. If you want to pause and try this one, go for it. Welcome back. Okay, domain. Or hi, if you didn't pause it. Okay, in the domain I see 0, a couple of 3s, a 5, and a 6. I'm going to list them in order. I don't need to list the 3 twice, just one time. I don't have to list repeating, but I'm making a note that it repeats. And then in my range, the lowest is -1, and then next would be 1, 2, 3, and 8. Because this domain has repeating x value, it would be a no. X repeats. It's not a function. And the last one, the most lovely one of all, I think, the vertical line test. Draw a vertical line. Do you see how this vertical line hits the graph 3 times? This means it's a no. It's not a function because x repeats. When you look at this graph here, I know it doesn't look like a straight line, but functions don't have to be straight lines. It just has to be a relation where the x doesn't repeat. And when I draw my vertical lines all through this graph, do you see how it only touches the graph in one place? That means that x doesn't repeat. So yes, this is a function. And you're finished for today. I'll see you tomorrow in class.